Hi!
Good day!
Today we're going to talk about alkenes and alkynes.
Alkenes have a carbon-carbon double band functional group, while alkynes have a carbon-carbon triple band.
Alkenes are named as if they were alkanes, but the "-ane" is changed to "-ine". For alkynes, the suffix changed to "-ine".
So, I'm going to show you how to name alkenes using the IUPAC rules. Here are the summary for alkene nomenclature. You should first identify the longest continuous chain atom that contains the double carbon band. Number the carbon atoms of the longest continuous chain starting at the end closest to the double band. So, 1. In this case, it should be numbered from right to left. For example, if the longest continuous carbon chain has 5 carbon atoms, the compound will be pentene. But in this case, since it has 6 carbon atoms, it will be named as hexane. The longest hydrocarbon chains have 6 carbon atoms, meaning it is a hexane. There's a double bond in the compound, so in order to indicate the double bond, the ending should be changed to "-ine" or hexene. If more than one double bond is present, the compound is named as diene, triene, or equivalent prefix indicating the number of double bonds, and each double bond is assigned a locator number.
Polymerization of
Next,
alkenes is a reaction that yields polymers of high industrial value at great economy, such as the plastics polyethylene and polypropylene. Polymerization can proceed via either a free radical or ionic mechanism, converting the double to a single bond and forming single bonds to join the other monomers.
Always be listed before
Another reaction is called the metal complexation.
In this case, the name of the substituent and it is in the
Alkenes
carbon
are
bond
ligands in transition metal-alkene
and it is in the
complexes.
fourth carbon bond.
The two carbon centers bond to the metal
Finally,
using
the
the
name of this
C-C-pi orbitals.
4-methyl hex 1-ene.
Alkynes form complexes with transition metals. Such compounds are sometimes useful regions or illustrate the role that metals play in catalytic transformations of alkynes.
Number 1 and number 2. Which of the two is number 1 may be determined by the nearest substituent rule. Like in this example. Like in the rules, you should first number your carbon chain. Since it has 6, it should be named as cyclohexane. Since it has double bond, the ending should be changed to cyclohexene. Next is indicating the number for which the double bond is placed. Since it has 2 double bonds, the ending should be diene. Next is for the substituents, which is placed at number 3 and number 5 carbons, which is methyl and ethyl. Finally, the final name should be 5-ethyl, 3-methyl, cyclohexane. 1,3-diene. And that's it.
The IUPAC rules are also used for the naming of alkynes. The first rule is find the longest carbon chain that includes both carbons of the triple bond. The second rule is number the longest chain starting at the end closest to the triple bond.
After numbering the longest chain with the lowest number assigned to the alkyne at its corresponding carbon,
While writing out the name of the molecule, arrange the substituents in alphabetical order. If there are more than one of the same substituent, use the prefixes di, tri, and tetra for 2, 3, and 4 substituents respectively. When there are 2 triple bonds in the molecule, find the longest carbon chain including both the triple bonds. Number the longest chain starting at the end closest to the triple bond that appears first. The suffix that would be used to name this molecule would be di-ine. For example, number the longest chain starting at the end closest to the triple bond that appears first. The suffix that would be used to name this molecule would be di-ine. For example, the name of this molecule would be 4-methyl-1,5-dioctadiene. 4-methyl because at the 4th carbon, a methyl is attached, and at the 1st and 5th carbons, there is a triple bond. The 4th rule is that substituents containing a triple bond are called alkenyl. For example, this is a cycloalkane and it is named as 1-chloro, 1-ethinyl, 4-bromocyclohexane. The last rule is that a molecule that contains both double and triple bonds is called an alkene. The chain can be numbered starting with the end closest to the functional group that appears first. For example, this is named as 6-ethyl 3-methyl 1,4-nonenine. Tapos na 9. Label each of the substituents.
Certain reactions open up a double or triple bond to insert various atoms, leaving only a single bond between the carbons. These are called addition reactions because atoms are added to the carbons that were previously double bonded. Probably the simplest addition reaction, and one that you've heard of, is hydrogenation, in which a molecule of hydrogen, H2, is added across the bond. To do this, a metal catalyst like platinum is usually required to help break the H2 apart because that bond is very strong. But once that's done, the hydrogen atoms readily attach to the hydrocarbon molecule molecule, converting a double bond to a single bond. Other molecules can break that double bond as well. If a halogen, such as bromine, is added in the place of hydrogen, the reaction is called halogenation. A water molecule, hydration, oxygen gas, oxygenation. You get the idea. The point is that double or triple bonds can be opened up fairly easily. Alkenes can be made into alkanes, and alkynes can become either alkenes or alkanes depending on how many atoms are added. And those opened bonds can also provide connections for carbon atoms to attach to each other too, opening the door for polymerization.
Polymerization of alkenes is a reaction that yields polymers of high industrial value at great economy, such as the plastics polyethylene and polypropylene. Polymerization can proceed via either a free radical or ionic mechanism, converting the double to a single bond and forming single bonds to join the other monomers. Alkenes are ligands in transition metal-alkene complexes. The two carbon centers bond to the metal using the c-c-pi orbitals. Alkynes form complexes with transition metals. Such compounds are sometimes useful regions or illustrate the role that metals play in catalytic transformations of alkynes.
Here are some applications. Alkenes are extremely important in the manufacture of plastics. All plastics are in some way related to alkenes. The names of plastics, polyethylene or polyethylene, relate to their alkene partners. Plastics are used for all kinds of tasks, from packaging to wrapping to clothing and to outdoor apparel.